Welcome, you teacher Black Adam, and then we're looking at the quadratic function, and that's our quadratic function there. That's f. And then we have the logarithmic function, that one there, that's g. And then we have point A and E. E and A, those are intercepts for the x. And then y-intercept at D. Turning point there at C, which is our value is 2. That's 2 there. So our turning point has a value of 2. And then we also have B there, which is 4, 2, 2. And then we have MCNR, which is a rectangle. Okay, so that's our rectangle there. We're told it's a rectangle. And then logarithm graph, where they say we should determine m, that's g of x is going to be log x base 2. Alright, but let's say it's base m, and then let's calculate. So we know that we have b at 4, y is equals to log x base m, and then substituting values at b, which is x is 4, y is 2. For b we have x is 4, y is 2, and then we have y is 2, and then our x is 4, and then we're solving for m. So we convert that logarithm into exponential, so it's m power 2 is equals to 4, and therefore we write 4 in the exponent format. So it's 2 to the power 2, so the exponents are the same, then the base has to be the same, so m is going to be 2. Our next question is to find the domain of g. So our domain for g, we have y-axis there, and then x is not equals to 0, that's the asymptote. So which means x should not be less than 0 or equal to 0, and that means x is greater than 0. That's our domain. So inverse, that's g to the power -1. Once again we write the equation, y is equals to log x base 2, because we already found our m is 2, and then writing that into log y base 2. So just trading x and y, then coming back, solving again, 2 to the power x is equals to y, and then we have y is equals to 2 to the power x. That's the inverse. So inverse of a logarithm is an exponential graph. So equation of h, 2 units to the left, which means that it's y is equals to 2 to the power x, because that's horizontal shift, plus 2. Right, so that's going to be to the left. So solving for x, there will be x is equals to x plus 2 is equals to 0. So that's our x equation for 2 units shifting to the left. Okay, and then we have f of x, show that a is equals to half, and then we have ax power 2 plus bx plus c, and then we know that we have point b and point a on the graph, and we also have turning point at c. So turning point there is going to be minus b over 2a. That gives us b, we have x is 4 and y is 2, that's x and that's y, and then we have 2 is equals to a bracket 4 to the power 2 plus b bracket 4 plus c. So we're using that, then simplifying further, it's going to be 2 is equals to 16a plus 4b plus c. So that gives us one equation. So we're gonna go and find another equation. Another equation, we can use another point, or we can use the turning point given. So at turning point, we have minus b over 2a. There it gives us 2, because the x there turning point is 2. So that's the equation, so that's 2. Now solving for b, so it's negative b times 1, and then 2 times 2a, it gives us 2 bracket 2a, it gives us minus b is equals to 4a. So solving for b there, b is going to be minus 4a. So that's our value for b. Now that we have there, we can substitute b there. So we have 2 bracket a 16a plus minus 4a. Okay, that's minus 4a plus c. That's going to be plus c is going to be 2 by 16a minus 16a plus c. So the a cancels out, so we have c there as 2. So that's our c2. And then we have at a, we have 5 is to 0. We have x there is 5, y is 0. And then we will have to substitute those values on the quadratic equation. So we're going to have y0 is equals to that equation there. That's a bracket 5 squared plus b bracket 5 plus c. And then from there we have to simplify. So we have 0 is equals to 25a. That will be 25a plus 5b. That will be 5b. Okay, so remember our b is negative 4a, so we substitute negative 4a there, plus multiplied by 5 plus 2, so we have 0 is equals to 25a, and then also the signs there, the multiplication, so that's going to be negative 20a plus 2, our c is 2, and that will give us a 0 is equals to 5a. 25a minus 20 is 5a. So that simplifies us as solving for a there. We have 5a is equals to negative 2, and then a is going to be negative 2 over 5. So that's our a value. So now let's look at b. B, we have a, so b is going to be a negative 4 bracket a negative 2 over 5. That's our value for a. So that gives us b as 8, positive 8 over 5. That can be simplified as 1, b is equals to 1 and 3/5. So that's it. So that's our final answer. And then we move on to the next question. The next question says, otherwise calculate the area of MCNR. So MCNR, we need to find some value. So we have y is equals to negative 2 over 5. So that's our original equation, and that's x there, and then that's 8 over 5x, x squared x plus 8 over 5 plus 2. So substituting value 2 at the turning point there. So we need to know that, okay, so if x is 2, what do we get? So we know that 2 bracket into 2 plus 8 over 5 bracket 2 plus 2. So x is equals to 2. Our graph touches at 18 over 5. So 18 over 5, that's our height there, 18 over 5. And the next thing we need to know the distance between n and the axis. So we need to use another graph there at n there. It's between c and n. We need to know that distance there. Okay, so our x there is 2. So when it's 2, the other graph, what does it give us? The g graph. So g of x is going to be log x base 2. So when our x is 2, which means it's going to be log 2 base 2. So that will give us 1. So it's like log 2 divided by log 2, 1. And then from there, n is going to be x to 1. So we know that our value there is 1. Now we can find our distance cn. So we need to find our distance cn. Our distance cn is going to be 18 over 5 minus 1. And then we know that our base is 5, so it's going to be 18 over 5 minus 5 over 5. So 18 minus 5 is going to be 13. So it's going to be 13 over 5. So that's cn. So MCNR is a rectangle. So by having a rectangle would mean that we have our base. Our base there is going to be base times height. So our base, okay, so this is our base there, which is 2. And then we have height 13 over 5. And then multiplying that, 2 multiplied by 13 over 5, that will give us 26 over 5. So that will be 5/1/5 units squared. Okay, and then we have the next question. It says, well, how can we explain when we actually go 4 units down, we'll have no roots? Okay, so the reason would be vertical shift downwards 4 units. Okay, so downwards 4 units. So we can go and have a look at how the turning point will be. This is the turning point, and then which means we're going to have 18 over 5, so that's 3 and 3/5. Yeah, 3 3/5, I think. So that's there. So we're gonna have our turning point there. So there'll be no, see, so that's a 10 point. So there'll be no x-axis. It's only gonna have y-axis. So no x-intercept. Therefore, no roots. No valid roots. So that's gonna be 3 over 5. Yeah. Okay. So from there we check the 2. We have 1 there and 5, and then the positive. So we need to multiply those graphs so that we give a positive answer. Okay, and then from there we need to know that, okay, x is going to be greater than 1, less than 5 on that interval. So that's where we can find the positive values when we multiply. So for that reason, the values of x, where the multiplication of the products with multiplication of the graphs will be positive, is between x less than x, 1 less than x, and x less than 5. Or x greater than 1, and x less than 5. Thank you so much for watching, and don't forget to follow or subscribe.